The moon isn't just our next destination. It's our next mine. For over 50 years the moon has stood as a symbol, a place we reached once and then left behind. But now, with NASA's Artemis program, that's all about to change. This time it's not just about planting another flag or leaving another footprint. This time we're aiming to stay, and to use the moon's own resources to push humanity farther than we've ever gone before. It's a bold new chapter, and it's just getting started. At the heart of this new plan is something exciting, a brand new rover. This isn't just another buggy like the ones Apollo used, it's a laboratory on wheels, designed to uncover the moon's secrets, like water, minerals, and everything we need to make a lasting home in space. Just recently, NASA revealed 3 new instruments that could shape the future of exploring the moon. These tools will either ride on or work alongside the Lunar Terrain Vehicle, the LTV. Think of the LTV as the Artemis Rover, a machine built to handle the tough landscape of the moon's south pole, which is the coldest and darkest part of the moon, and also the best place to search for ice. Unlike earlier missions, this time it's not just about science for the sake of science. It's about finding resources that future astronauts will count on to live and work far from Earth. The LTV is being built to map out where those resources are, how deep they go, and how we might use them in the future. When it comes to exploring the moon, NASA is combining careful precision with the ability to reach far and wide. 2 of their new instruments will actually ride along on the rover itself, while a third will scan the moon from way up in orbit. First up is ARES, that stands for Artemis Infrared Reflectance and Emission Spectrometer. Using both visible and infrared light, ARES can spot the chemical fingerprints of things like water ice, ammonia, carbon dioxide, and other important minerals. With its wide-angle imaging, it'll help turn the lunar South Pole into a detailed map of resources, showing exactly where future astronauts should head next. Next, there's LMAPS, the Lunar Microwave Active Passive Spectrometer. This one looks beneath the surface, using radar and microwave sensing to probe as deep as 40 meters below the ground. Why does that matter? Well, buried ice isn't just frozen ground, it could be the key to survival. That ice can be melted for water to drink, split into oxygen for breathing, and hydrogen to fuel rockets. In other words, finding it could mean the difference between just visiting the moon and actually staying there for the long haul. And finally, there's UCIS Moon, the Ultra-Compact Imaging Spectrometer. This one doesn't ride on the rover at all. Instead, it orbits the moon, scanning huge areas from above. Its big-picture view gives scientists the context they need, showing how the rover's discoveries fit into the whole South Pole region. Together, these 3 instruments create a layered approach to exploration. Up close, underground, and from orbit, it's NASA's most complete effort yet to truly understand what resources the moon has to offer. You might wonder, why go to all this trouble? Well, water on the moon could change everything for us. Water isn't just something to drink. We can split it into oxygen and hydrogen. That means air for astronauts, and rocket fuel for our spacecraft. This idea is called in situ resource utilization, and it could completely reshape how we explore space. Instead of hauling everything from Earth, which is incredibly expensive, future missions could just refuel right there on the moon. The moon could actually become our first pit stop on the way to Mars. That's why Artemis is aiming for the South Pole. Those craters that never see sunlight might be hiding frozen water that's been untouched for billions of years. If NASA can find and use that water, the moon becomes more than just a destination. It turns into a supply station, and NASA isn't doing this alone. Companies like Intuitive Machines, Lunar Outpost, and Venturi Astrolab are all in the race to build the Lunar Terrain Vehicle. NASA picked the instruments for the mission on July 10, 2025, kicking off a crucial phase of development. By the end of 2025, NASA plans to choose the final rover design. Once it's ready and on the moon, the LTV will be a real workhorse. Astronauts will be able to drive it for up to 8 hours each lunar day, and when there's no crew around, it'll run on its own, still scouting and collecting data. It's designed to travel up to 20 kilometers across some of the toughest terrain in the solar system, and it can carry up to 800 kilograms of gear, samples, and tools. This isn't just a short-term machine, it's built for repeated missions, gathering data that will help shape NASA's long-term plans for the moon. 50 years ago, the moon was all about achievement, a way to show what humanity could do, but today, it's about survival, and reaching even further. The Artemis rover is the symbol of that shift. It's not just there to snap photos or collect rocks. It's on a mission to find the resources that will let us stay for good. The data it brings back will help NASA decide where to land, where to build, and where to dig. It could even pinpoint the spot for the very first lunar base. And from there, it could help create the supply chains that one day send us all the way to Mars. So next time you look up at the moon, remember, it's not just a distant light in the night sky anymore. It's about to become part of Earth's economy, a place where we learn to live beyond our home planet. The Artemis Lunar Terrain Vehicle is more than just a rover. It's the beginning of a future where the moon isn't just visited but truly used. Imagine a future where space exploration isn't limited by what we can bring from Earth, but powered by what we discover out there. And if NASA pulls this off, the moon won't just be our next step, it'll be our foothold on the path to the stars. Interested in more space news? Leave a like on this video, subscribe, and turn on notifications so you never miss a new episode about space exploration.